everyone, welcome to today's video. Today we would be explaining how sequence-to-sequence model work, where we would be having an introduction to encoder-decoder architecture and discuss how it revolutionized the machine translation and chatbots. So let's begin. Have you ever wondered how Google Translate instantly converts "How are you" to "Aap kaise hain"? It's not just replacing the words, but it's understanding the meaning. But how does the AI actually does it, right? So here, what used to happen is during your earlier models, there was a word-to-word translation that used to happen. But this kind of translation fails because different languages have different grammar and different structures. For example, in English, you will say, "How are you?" In Hindi, you will say "Aap kaise hain," which literally means "you how are," right? If we just do a translation from word to word or transliteration from word to word. So this is where the sequence-to-sequence model helped, where it was a deep learning architecture which was used to do number one, machine translation, like "How are you" to "Aap kaise hain." Number two, for question answering sessions, where you will have sort of an encoder-decoder model. We'll learn that in the coming video. But in the encoder side, you will give questions and then the decoder will train itself for giving you the answers. So now, before we jump to that, let's try to understand what was the problem with these older translation approaches, right? Where we had LSTMs and RNNs. So the major problem that we were facing with these older translation approach was it was more of a word by word translation, and that fails, right? Because in English, if you have something like "I'm eating an apple," right, and in Hindi, the same thing would be translated to "मैं हूँ खाना एक सेब," which is incorrect, right? The correct would be "मैं एक सेब खा रहा हूँ." So the different words in the languages, in different languages, have different word orders. So for example, the English always follows a subject, verb, object sort of a syntax, where for example, he eats mangoes, and Hindi follows a subject, subject, object, verb kind of a syntax, where you will have "वह आम खाता है," which literally means he eats mangoes. So the sequence-to-sequence model were solving these kind of problems by understanding the complete sentence and not just transliterating the words themselves. So let's now try to understand the encoder-decoder architecture itself that we are talking about in this particular video. So the encoder architecture was for understanding the input. The encoder architecture will read the entire input word by word and convert it into a fixed size vector known as the context vector or the hidden state. The vector will act like a summary of the sentence. So for example, if I have an input sentence, "They are watching," and EOS is just a tag that I have taken for end of sentence, then the encoder will process "they are" and "watching," and then finally in the final end of sentence, this would be your final hidden state or the context vector. So now this context vector holds the meaning of the entire sentence which is passed through the encoder layer. Now for the decoder layer, this would be used for generating the outputs. Now how does the decoder layer works? So for example, the decoder layer will take the context vector and generate the translated sentence word by word. Now how does it work exactly? The decoder layer starts with an empty token and generates word one at a time using the context vector and the previous words. So it learns to predict the next word based upon the input words which is given to the that particular layer. So now this is just lazy copy pasting. I couldn't find a Hindi version of the decoder layer, so you will see something like "They are watching," and then you will have, I'm guessing this is French, correct me if I'm wrong, but something like something like "les regret," and I'm sorry for my accent, but you will find something like this in the decoder layer. So this is just lazy copy pasting, nothing else, but you get the idea, you get the concept over here, right? If I take a Hindi example, then you will have something like "I love learning NLP," which would be given to your decoder layer, and then you will have in your encoder layer, and then in your decoder layer you will have something like "मुझे NLP सीखना पसंद है," or something like that, right? Now talking about the decoder layer itself, it will start with some empty sentences and it will generate word one by one using the context vector from the previous words, and it learns to predict the next word based upon the input's meaning. So that's how your decoder layer works and gives you a final translation from "I love learning NLP" to something like "मुझे NLP सीखना पसंद है." And this method allowed AI to generate fluent and natural translations. Now, where exactly are these sequence-to-sequence models used? Let's try to understand. next. So that's where these sequence to sequence models were then used for used by Google Translate, chatbots, text summarization, and text to speech kind of systems. So text to speech systems which will convert spoken words into speech to text systems, where it will convert your spoken words into texts in sequence basically. So sequence to sequence model brought AI one step closer to understanding the human language, right? Now, but of course, it comes with its own limitations, right? Otherwise, we would have stopped at sequence to sequence models, and we wouldn't have the current models that we have, the state of the art models that we have, right? So the sequence to sequence models were great, but they had one big problem. They struggled if with long sentences. If a sentence is too long, then the context vector usually forgets the important details. So, for example, if I have in English a boy who lives near the mountains and loves to paint suddenly disappeared, the same sentence that we used in LSTM and RNN. So, now you want to translate this into Hindi, you will have something like लड़का पहाड़ पास रहता गायब, something like that, right, where it is missing the key information. The correct translation should have been something like जो लड़का पहाड़ के पास रहता था वो पेंटिंग करने और उसे पेंटिंग करना पसंद था. Oh my god, I am now trying to be more like a sequence to sequence model rather than paying attention to the important details. But जो लड़का पहाड़ों के पास रहता था और पेंटिंग करना पसंद करता था वो अचानक से गायब हो गया, right? This should have been the actual sentence. So, but that was the limitation of sequence to sequence, where it will give you a bad Hindi translation, something like ladka pahad paas rehta gayab, something like that, right? So this is where you had models such as attention, you had mechanisms such as attention mechanism, which we will try to explore in the next video. And this was a big breakthrough in AI that helped us to focus in most important words while translating. So stay tuned for that. And if you can think of a sentence that would be very tricky for AI to even understand now, drop it in the comments and let me know. And yeah, I'll see you. Subscribe for, and don't forget to subscribe for our next episode on the attention mechanism, the game changer. The everything about the chat GPT and everything was from this attention mechanism itself. So share it with someone who might.